This next video is going to jump around a little bit. There's also some stuff in it that technically you don't need to know this year. You don't need to know the different types of evolution, but I find it very difficult to teach you the topic of comparative anatomy or structural morphology and not have at least an overview of what these processes are. So the very first one that we're going to talk about is actually, we're going to go back to page 6 in your notes. So I said page 6 wasn't really included. I said the bottom half of page 6 wasn't included. So you don't need to know the divergent and the convergent evolution. So you can pause if you need to go get your book. All right, if you've got your book and you've got it open on page 6, we're doing well. But I do want to teach you about these words, which you should have heard in year 10, about these things called homologous structures and analogous structures. I just don't trust them for not writing an exam question that includes these. So the first one that we've got here is homologous structure. So a homologous structure, homo meaning the same, and logous meaning kind of shape or something like that. So what we've got with the homologous structure is they all have similar structures underneath them, but they all have very different functions. So the best example of this is what we call the pentadactyl limb. So you're probably going, oh, I remember that. I heard that in year 10. Now you're saying pentadactyl limb. So homologous structures have the same kind of bones, but they have different functions. So the good example here is that we have an arm here. We have phalanges. Yeah, these little bones down the end here. If you looked in a cat's paw, they would also have the phalanges. If you looked in a whale's fin, they would also have phalanges. If you look in a bat's wing, they also have phalanges. So we are all mammals, aren't we? So it kind of makes sense that we would have similar bone structures because we probably diverged from other groups a little bit later, and that we're going to go into in the next subtopic. So you can often find comparative homologous structures in different dinosaurs as well. So these are things that must have a recent common ancestor. If you have similar bones to something else, then that suggests to me that you came from a common ancestor, or you must have it's more important that you have a common ancestor, yeah? So it's really important with this one is that if you have a homologous structure, you must have a common ancestor. Now, these are often an example, and again, don't need to fill in the notes on divergent evolution because you shouldn't be asked, but I'm going to go through it anyway because I cannot believe that they've cut this little bit from the course. So divergent evolution is when organisms come from one ancestral creature, one ancestral mammal, for example, gave rise to all of these different animals because they occupy different niches or different roles within a habitat or an ecosystem. So they come up with these different niches, and this is what actually drives speciation. It drives the whole process of evolution. Most of it has happened through this divergent evolution. The other word that you might see in some of your past exams is this term adaptive radiation. It just means the same thing. They kind of radiate out from an ancestral organism due to their different adaptations. The opposite of this, the opposite of an analogous structure, back at the top of page 6 again. Now, these are called analogous structures. So analogous structures, and again, I'm just going to pause to get our etymology up just to make sure. Not much help. Yeah. So although homologous is that they have the same kind of ratios and same structures, so they have the same bones, analogous actually means, and I'm just going to double check what I've written here, is that, oh, it's gone away. That's helpful, isn't it? It means that they're proportionate to each other, which doesn't help us with this, but homologous definitely does. Homologous means that they have a similar structure. So an analogous structure is a bit weirder. Analogous structures are ones that look like they might have a common ancestor on the outside because they perform a similar function, but they have a completely different structure within them. So here is a bird's wing. bird's wing, and here is an insect wing which doesn't even have any bones in between it. Now they both perform the same function or very similar functions, allowing the organism to fly, but they have very different structures, and this is because similar selection pressures have acted on them. So with the homologous structures, different selection pressures acted on them to drive them apart. With the analogous structures, they've arisen because similar selection pressures have acted on birds as they have on some of the insects, and as a result they've both developed the ability to fly. And so this is what we link back to this theory of, let's just see if I can get any of my pages to move. No. There we go. This is evidence for convergent evolution. Again, not on the course in 2020, but it is really difficult to teach you about comparative anatomy without going through these. So here is the analogous similarity between a platypus and a duck. They both have kind of feathery or very waterproofy materials on the outside. They both have bills, although one is a bird and one is a mammal. So they both lay eggs. So they might have come from different ancestors, but they have actually converged and come together. So you've got another example of analogous here. You've got the fact that you've got a fruit bat, which is a mammal, a pterosaur, which is a dinosaur, possibly a reptile, and then eastern bluebird, which is a bird, and they all have the ability to fly. Here's another picture just outlining the difference between a homologous structure, similar bones or similar underlying structure, different function, and analogous structure, different structures underneath, similar function. Here's another one showing you really interestingly, I love looking at how different all of these different swimming appendages look like when you look in the middle, in underneath. So this is due to similar selection pressures, and this one here is due to different selection pressures. Now I know it's not on the course, but I can't not teach it. It doesn't make sense. And then we get all the way through. So I want you to pause if you need to and go all the way down. I'm just doing it now to see how long it's going to take. You'll see that there is, this picture is on page 11. So if you need to pause here and write down the annotations that I've got here, they have, remember the homologous has similar structure, different function, whereas analogous has different structures but similar functions because of those similar selection pressures. We are now up to page number 12, and we're going to try and get just a little bit on vestigial structures done up the top here because they're really cool. So vestigial structures are bones or parts of an organism, not necessarily bones, that don't have a function anymore, but they're kind of left around in our bodies or in bodies, and they give us kind of an indication of our evolutionary history. So if you look at humans have a little bit at the bottom of our spine called the coccyx. You may have slipped and fallen and accidentally hurt your coccyx before, but that serves no purpose anymore. So what we think it is we think that it used to be a tail. So it's evidence that we may have used to have a tail. How cool is that? In addition to that, if you look inside whales actually have these weird little floating bones in the back here. They're pelvic bones, and they indicate that whales may have once had 4 legs. So that's pretty cool. They've just got some leftover leg bones hidden in them. They serve no function, but they are evidence that they were once walking on land. In addition to that, if you're one of those people, I can't do it. If you could move your ears independently, I can't do it. Some people can like move their ears up and down. That might be because you have a vestigial structure. Your wisdom teeth. Yeah, your wisdom teeth are definitely a vestigial structure. Another vestigial structure for us is actually our appendix. Not much use to us anymore. So again, ouch, ouch, ouch. And I know some of you really feel this one when I put it up here. The wisdom teeth used to serve a purpose when we had a much rougher diet to be able to grind apart food, but because we don't have that anymore, they're just now redundant, and if they cause infection, we get them removed. So that should finish us off. There's only one little bit left of this booklet, and then we're all done.